Hello everybody, welcome to topic number 7, graphing equations and functions. For objectives today, we're going to learn about how to graph ordered pairs, we're going to determine whether an ordered pair is a solution, and we're going to show you tips and strategies for graphing different linear equations. So here are some key concepts and definitions we're going to talk about when we talk about the rectangular coordinate system. First, we have an ordered pair. An ordered pair is just two numbers associated with a point on the graph. The first number gives the horizontal location of the point, and the second number gives the vertical location of the point. So for example, if I wanted to go and graph a point here, where my blue dot is, we would first count horizontally, moving left to right. So 1, 2, 3, 4 to the right, and then 1, 2, 3 up. The coordinate is a number in an ordered pair. It's always written as an x and a y coordinate. So for example, 4, 3 is the xy coordinate we have. X in this case is 4, and y in this case is 3. The x-axis is the horizontal line number. The y-axis is the vertical line number. The origin is the point of intersection of the two axes, and the origin is always located at 0, 0. So it will be this middle point right here in the graph. And the quadrants are four regions created by the intersection. So you can kind of see we've got four quadrants here. Quadrant 1 is in the top right corner. Quadrant 2, top left. Quadrant 3, bottom left. And quadrant 4, bottom right. I always tell people to remember the way the quadrants go. You make a big C, and from start to finish, that's your way to remember the quadrants. Each quadrant has different signs. So for example, the 4, 3 I have in quadrant 1. Anytime I go to the right, it's a positive number, and anytime I go to the left, it's a negative number. So that's why this 4 is positive. And for the 3, I went up 3. When you go up, it's a positive number, and when you go down, it's a negative number. So anything I graph in quadrant 2 will be a negative positive. So for example, if I wanted to graph this point right here, 1, 2, 3, 4 to the left, so negative 4, 1 up, and positive. Anything I graph in quadrant 3 is negative, negative. So for example, if I wanted to graph this point right here, 2 to the left and 1 down would be negative 2, negative 1. And then quadrant 4 would be positive, negative. So for example, if I wanted to graph this point right here, it would be 4 to the right and 1 down. When we talk about the x and the y-axis, if I graph points there, they're always going to have a 0 because they're not going to go some direction. So for example, if I were to graph this point right here, I go 4 to the right, but I also go 0 up or down. Same thing with the y-axis. If I wanted to graph this point right here, I went 3 down, and down is a y movement. So I didn't go any left or right, and then I went 3 down. Later on, we'll learn that these are called x-intercepts and y-intercepts. State in which quadrant or in which axis each of the points lie. So point A is right here. If you notice, it's not in any of the axes, it's on the y, in any of the quadrants, it's on the y-axis. So this will be located on the y-axis. And this would be the point 0, 4. Point B is located down here. This again is quadrant number 3. It's the one where everything is negative. So this point would be negative 3, negative 2. Point C is located in the top right. That is quadrant 1, where all the values are positive. So that is the point 4, 2. D is located in quadrant 4, bottom right. It's where the x values are positive and the y values are negative. And point E is not actually located in a quadrant because it's located on one of our axes. This time it's going to be on our x-axis. So it doesn't go any up or down. So we would call this point 5, 0. To determine whether an ordered pair is in a solution, all we're going to figure out is if it comes out to give us a true or a false statement. If it's true, it's an ordered pair that is a solution. If it's false, it is not. So here we're going to determine if this is a solution of this. Remembering that the first part is the x, and the second part is the y. So I'll take this equation, I'll go 2 times 3 plus 5 times negative 2, and my job is to see if it equals negative 4. 2 times 3 gives me 6, 5 times negative 2 gives me negative 10. Does 6 minus 10 equal negative 4? Yes, it does. So is this a solution to the equation? Yes, this would be a solution. We'll do the same here for this one. Again, the first part of the coordinate is the x, the second part is the y. So we have 3 times negative 1 minus positive 6 is equal to 5. So 3 times negative 1 is negative 3 minus 6, and our job is to see, does that equal 5? Well, negative 3 minus 6 is negative 9. So does negative 9 equal 5? We would say no. This is not a solution to the equation. So a solution is when you're able to plug in a coordinate and it comes back as a true statement. Now let's take you to the main objective. Our goal is we want to go through and graph linear equations. One of the ways we're going to do that is we're going to put things in what's called slope-intercept form. You've probably seen slope-intercept form before. This is the one where we say y is equal to mx plus b. There's two important components of this. B is the y-intercept, and m is the slope. The y-intercept is going to tell us where we start our graph, and the slope is going to tell us how we move. So when we go through and graph linear equations, we're going to follow two steps. The first thing we're going to do is graph the y-intercept. And the y-intercept should always be located on the y-axis. So our first point is going to be somewhere located along this y-axis here. If it's a positive y-intercept, it'll be located to the top. If it's a negative, it'll be located to the bottom. Our second thing is we're going to move using the slope. For the most part, our slope is either going to come out to be positive or negative. So if we have a positive slope, we're going to move up first and then to the right. If we have a negative slope, we're going to move down first and to the right. And we're going to move from the y-intercept. Once I have those 2 points, I'll be able to graph any equation. So for example, if I wanted to graph y equals 1 over 3x minus 4. Negative 4 is our y-intercept. That's telling me I need to start 4 below the x-axis. So we'll go down here and we'll find 4 points below. 1/3 is our slope. In this case, it's a positive slope. So we're going to go up to 1 and to the right 3 from the y-intercept. So from the y-intercept, we will go up 1 and then to the right 3. So here's my up 1, here's my right 3, and then from there we can graph our equation through those 2 points. So our objective is always, we want to find the y-intercept and we want to find the slope. Notice as we do this, our equations are always solved for y. So if they're not solved for y, we can do that first, and then it should make it easy to graph it in slope-intercept form. Let's take you through some examples. I'm going to start with b. Y equals 2x plus 3. So the first thing I notice is that 3 is the y-intercept. This is my starting location. So it's a positive 3. I'm going to start 3 up from the origin. 1, 2, and 3. I'll put my first dot there. The 2 is my slope. Now, we always like to write slope as a fraction, and any number that doesn't have a fraction bar underneath it, we could turn into a fraction by putting a 1 underneath it. So 2 and 2 over 1 are the same thing. Because it's positive, we're going to go up 2 first, and then to the right 1 from our y-intercept. So from here, we'll go 2 up and 1 to the right, and we'll use that to graph our equation. Let's do the same thing for letter C. It's negative 2x plus 1. Here the y-intercept is 1. So we're going to start 1 above the origin. Now my slope is negative 2. Again, I'll turn it into a fraction by putting a 1 underneath it, but this time it's negative. So we're going to move down 2 and to the right 1. We always move to the right when we do the bottom number. So from here, I'll go 1, 2 down, and 1 to the right, and then I'll be able to graph my equation. Now, the only thing different about A compared to when you see B and C is that there's no number at the end. That means it's really like a plus 0. And the 0 is what we've been calling the y-intercept. So if there's no number at the end, that means our graph starts right in the middle at the origin. Our slope is still 2. We could call it 2 over 1. So we're going to go up 2 and to the right 1 from the origin. So from the origin, we'll go up 2 and to the right 1, and we'll connect our line. So if we don't see a number at the end of our slope, that is just telling us that the y-intercept starts in the middle. Let's do a couple more. Y equals half of x minus 2. Here, the y-intercept is negative 2. That means I'm going to start 2 down from the origin. 1, 2. So here is my first point. My slope is 1 over 2. It's positive, so we're going to move up 1 and to the right 2 from this point. So from this point, we'll go up 1 and to the right 2, and we'll connect our line to graph it. Now for E, we notice this value isn't solved for y. We want to be able to go through and solve for y in order to be able to put it in slope-intercept form. So we can do that by what we learned earlier in the class. We're going to go through and move things to get y by itself. In this case, I got to get rid of the positive x, so I'm going to subtract the x to the other side. 2y is equal to negative x plus 6. Now you'll notice I put the x first because, again, I want it to be in y equals mx plus b form, so I always like to have the x part first. Next, I'm going to divide everything by 2. And by doing that, I get y by itself. Y equals negative x over 2. And again, there's no number here, so if we need to, we could put a 1 there. So this is really y equals negative 1/2 x, and 6 over 2 gives me 3. This we can now graph. It tells me my y-intercept is at positive 3. So I'm going to start 3 up. My slope is negative 1 over 2. It's negative, so I'm going to move down 1, and I'm still going to move right 2 from the y-intercept. So from the y-intercept, I'll move down 1 to the right 2, and then I can go through and graph my equation. Let's try it again for F. My goal is to get y by itself, because when y is by itself, it's in slope-intercept form. I'm going to take the 3x and move it to the other side. It's a positive 3x, so I will subtract it. Negative 2y is equal to negative 3x plus 12. My job is to get y by itself, so I'm going to divide everything by negative 2. Y is equal to Now here I've got a double negative. Two negatives make a positive, so this will end up being 3 over 2x. 12 divided by negative 2 is negative 6. This is what we can graph. Negative 6 will be our y-intercept. My graph only goes to negative 5 here, so we're going to assume this point right here is negative 6, but we go 6 down on the y-axis. The slope of this ended up being 3 over 2. So I'm going to go up 3 and to the right 2 from this point. So 1, 2, 3 up, 2 to the right to graph my next point, and then connect the dots to get my answer. Again, we're starting from the y-intercept and we're moving to the slope, and we're not putting that second point until we've moved completely from the slope. And as long as you have 2 points, you can graph any equation. Another way that we can find and graph things is by finding their intercepts. So again, we talked about earlier, if we have a point that ends up here on the x-axis, it's always going to be a point that is a number and 0. This is known as an x-intercept. To find an x-intercept, we let y equal 0 and we solve for x. If we find a point on the y-axis, it's always going to be 0 and some sort of number. This is known as a y-intercept. To find a y-intercept, we let x equal to 0 and we solve for y. So, if you're kind of reviewing, if you want to find an x-intercept, you set the y equal to 0. To find a y-intercept, you set the x equal to 0. If you set the opposite letter equal to 0, you will find the intercept for the other letter. And then you can go through and graph it. As long as you have both intercepts, you can also graph those. Let's try it here. Graph this using intercepts. First, let's start with the x-intercept. To do that, we're going to set y equal to 0. So we're going to take 4x minus 3 times 0 equals 12. Well, negative 3 times 0 just cancels out because that's 0. So all I'm left with is 4x is equal to 12. Dividing by 4, I get x is equal to 3, which means my x-intercept is located at 3, 0. It's a positive 3, so I'm going to move 3 to the right and place my point. Remember, an x-intercept always happens on the x-axis. We're going to start over and do the same thing for the y-intercept, but this time we're going to set x equal to 0. So taking the same equation, but now it's 4 times 0 minus 3 times y equals 12. The 4 times 0 becomes 0, so all I have left is negative 3y equals 12. And dividing both sides by negative 3, I get y is equal to negative 4. So my y coordinate is at 0, negative 4. It is 4 below the origin. And then we can go through and connect and graph. So another way you can find 2 points is also by finding the x and the y intercepts. Let's look at this problem. We want to graph y equals 2/3 of x by finding and plotting its intercepts. Let's start with the y-intercept. Well, to find the y-intercept, I need to set x equal to 0. So I've got y equals 2/3 of 0. But 2/3 of 0 just cancels and leaves me with 0. So the x-intercept is at 0, 0. It's at the origin. But you'll notice if this actually happens, this is both the x-intercept and the y-intercept. The origin is the one point that crosses the x and the y-axis. So I'm not going to be able to find another intercept to be able to do this. So the only thing I can use from here is its slope to move the point. I know that the slope is 2/3, so I should be able to move up 2 and right 3 from the point in the origin. So from here we'll go up 2 and to the right 3, and then we can go through and graph. So anytime you don't have a y-intercept, you're not going to have something that has 2 intercepts that are different. It's always going to go through the origin. The lines that we haven't talked about are vertical and horizontal lines. Vertical lines have a graph where x is equal to c, where c is a real number. So the way I remember this, when we write an equation for a vertical line, it's always x equals and then some number. That number will be whatever it goes through with the x-axis. So for example here, this would be x equals 2. For horizontal lines, it's the opposite. It's y equals some number. That number depends on where it crosses the y-axis. So for example, we see that this one crosses the y-axis at -4. So this would be y equals -4. So whenever you see x by itself, it's asking you for a vertical line. And whenever you see y by itself, it's asking you for a horizontal line. That's a little trick that you can remember when you go and graph these. Let's try it here with these. I've got y equals -4. And to us, we have to remember y equals -4 will end up being a horizontal line. So I'm going to go through and I'm going to draw a horizontal line that is at -4. 1, 2, 3, 4. So we'll draw a line that goes through like that. This is y equals -4. X is a vertical line. So I need to draw a vertical line that goes through at 5. 1, 2, 3, 4. Here's x at 5. So I'll draw a vertical line that goes like this. Now for the other two, you'll notice that x and y aren't by themselves. First, we're going to get them by themselves. So for C, I'm going to add 2 to the other side to get y by itself. And when I do that, I get y equals 2. Y is still a horizontal line. So I need to draw a horizontal line that goes through y at 2. Being positive, that means I move 2 up from the origin. So this line would go through right here. Same thing with the x. I want to get x by itself, so I need to subtract 3 to the other side. In this case, I get x equals -3. X is always a vertical line, but now I need to move 3 to the left. So from the origin, I'll move 3 to the left, and this will be my line right here. So again, if you see an x, that is a vertical movement. And basically this number is telling you how much you move to the left or to the right. If your equation just has a y, then it is a horizontal line. If it's a positive, it's a line above the x-axis. If it's a negative, it's below. If your line has both a y and an x, like all the other problems we've seen, then it will not be a horizontal and a vertical line. It will be a slanted line. That is a great way to help you remember how to graph horizontal and vertical lines.